Today we are going to see the concept of queue, and the type of queue that we are going to see is circular queue. We are going to conceptually understand. I have already written down the pointers. Once we understand the concept, then we can switch to our programming and our functions that are important grammatically. So let's try to get into the topic and understand it in detail. The very first pointer we start with is extended version of linear queue. So we already know our queue concept, right? Queue would be represented something like this if you remember. Linearly stored values. Okay, so our circular queue is going to be an extended version of a queue. Okay, FIFO principle, first in first out principle. Okay, so we know we had the concept of front and rear, and we had values inside this. Okay, so when I was supposed to insert, my rear would increment and I would insert the element. If I want to delete, I'll increment my front and delete the element. So first in first out principle. So circular queue also follows a similar principle. The second point that it says is connects last node of the queue to the first node. Now we say it's circular, so there this concept of connecting your last node to the first node, that is what makes it circular. Okay, we're going to understand how a circular queue works, but before that, let's try to understand why circular queues. Now earlier when we had the concept of queue, we were inserting the elements and we were deleting the elements, right? From one end we were inserting, the other end we were deleting. Now suppose this is my queue, I've already inserted to my max size. Now I'm deleting some elements, so my deletion would happen from front, and my front is pointing here, right? So here the elements that are deleted has created a vacant space, but due to the concept of my queue, I'll not be able to insert elements here. I can insert element only by incrementing my rear, and my rear has already reached its max size. So even after having space in my queue, I am not able to insert elements. So this space goes unused. So to eliminate this drawback, there's the concept of circular queue. So my end is connected with my start. So this pointer says connects the last node of the queue to the first. So my last node will be connected to the first. User wants to insert the element. So if the user wants to insert, the next element would be inserted here. That is the reason why circular queue. Okay. Next point, it says ring buffer. This particular concept is also called as ring buffer. Next we have is functions or operations inside our circular queue. They are isEmpty, isFull, enqueue and dequeue. So isEmpty is checking the condition whether my queue is empty for me to insert elements. IsFull is checking the condition that whether my queue is complete or filled with elements. Enqueue is basically insertion, and dequeue is deletion. Right? Already we have seen the concept. So these are the basic operations. With that we have peek, we can have traverse or display your circular queue. Okay, these are the basic functions that you perform. Now we have enqueue and dequeue. With that, now when I have a circular queue, your circular queue would be represented something like this. Right? 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. So your last element is connected with your first. The maximum size is 5 elements for this particular circular queue. My last node is connected with my first node. Last node connected with my first node. With that, when I'm inserting the element, my insertion will start from this place itself. So my front and rear would be -1 at the start when my queue is empty. The moment I want to insert the element, I will pick them up and put it at 0th position. So here will be my front and rear. Okay. Then I want to insert the element, I will just increment my rear. For insertion, I'll increment my rear. When my rear will now point to this. Rear is 1, front is still 0. I'll insert the element. So my first element is already inserted. I'll insert the second element. I want to insert one more element. My rare will be again incremented. It will point here, and I'll insert the element. Again, if I want to insert the element, my rare will point here. I will insert the element. Okay. Again, if I want to insert the element, my rare will point here. I will insert my element. Can you see that? Now, I want to delete the element. I know that first in, first out. So whichever element is at my first, that is front, from there my deletion will start. So I'll have to increment my f. So my f, which was 0, will now increment to 1. Automatically this element will be deleted. I'll increment my f to 2. This element would be deleted. Right? But now circular queue says what? That if I want to insert the element, my end is connected to my first, right? My end node is connected to my first node. So then I can still insert the elements if the space is vacant. Now how do I check this condition to insert elements? Because we know that I increment my rare. So my rare is pointing here. To insert the element, what is the condition? Rare plus plus. Now if I do rare plus plus, what is going to happen? 4 plus 1, that is 5. My rare will become what? 5. My maximum size is 5. That is, it starts from 0 till 4. It is exceeding. This condition says overflow. When I do rare plus 1, here in this case, if I do rare plus 1, it is going to increment the value. And that condition is going to be overflow condition. That is, I am going beyond my queue, circular queue. Now that should not be the case. The moment I reach my end, I need to point here. My rare should point here so that I can insert element here. So for that, this is the line. What do I do? Rare equal to rare plus 1 mod of max size. Rare is equal to rare plus 1 mod of max size. Now let's try to understand this. Okay. So my rare has reached here. It wants to insert an element. Okay. So when it wants to insert an element, so now I want my R to increment, but it should increment to 0th position. So for that, what I'm going to do? Rare equal to rare plus 1. Rare is equal to rare. What is my rare? That is 4 plus 1. Okay. Mod of max size. What is my max size? 5. Now if you calculate this, 5 mod of 5, that is equal to 0. So my rare now is 0. So my rare, which was here, now will point to this. And I will insert my element here. So this line is important. Now you will say, how are we supposed to know that we are going to perform this? We are supposed to perform this by putting an if condition. And that if condition is going to say, if my rare has reached its max size. If my rare has reached its max size, then perform this. Clear? So that is the concept of circular queue. Very important. Might find confusing at the starting, but if you go through the points again, and if you draw the circular queue by yourself, try to understand insertion and deletion, work on the front end rare, it will be much more easy for you to understand. Okay.